Hello everyone, let's talk about dictionaries. Remember our chart from the previous video. Dictionaries are key value pairs delimited by curly braces. They are similar to sets. The keys cannot be duplicated, and if you think of a set as a dictionary with no values, then the two have a lot of commonality. And we'll look at some examples and write a little bit of code together. Here's our first example. I took the code off the slide, pasted it into a brand new, shiny, empty Jupyter Lab notebook. This one has key value pairs representing colleges and then their mascot names or their team names. There are 4 key value pairs for sets, and we can index by the key whoops, if you spell the key right. And that returns the corresponding value. If you don't specify an existing index, let's spell it wrong on purpose. Cincinnati with 2 N's instead of 3. We get a key error, and it's an error, but it's to be expected. Sometimes you'll search for a key that's not there. The moral of the story being, don't use this syntax unless you've got some error handling built in where you're 100% certain that the key does exist. And I think on the slide, I'm skipping ahead a little. I'm skipping to slide 6. We can use the get function instead of that indexing notation, those square brackets. And we can read a key value pair. We can use a key to read a value. And if the key does not exist, it won't throw an error. It's a little more behaved. So let's try that. I will comment out in my notebook the incorrect or the key error. I'll add another line of code. Let's actually store it to a variable this time. My value equals my dictionary dot get. Not square brackets, we're calling a function. We're going to use parentheses. Misspell Cincinnati, and then print the value. When we do that, we don't get an error, but we get none, which is an indication that it's null or empty or undefined or not provided. But it's still interesting. I'm still curious. I hope you are. What data type is this thing that is represented by none? And it is a none type. So there's a new data type for us. It's a data type that represents nothing. Now what if it had worked? Let's reproduce this code and let's spell it correctly this time. So when this runs, this new set of code will successfully find the key Cincinnati spelled correctly. It will return the value, store the value in our variable called myValue, and we're curious to see what data type myValue is now. and it's a string. Interesting, then we learn that the get function on a dictionary returns something of type non-value, I'm sorry, non-type, if it cannot find the key in the dictionary. How about adding a key to a dictionary? And I'll continue working with my wonderful little dictionary that I already created. One syntax we can use here looks suspiciously like indexing syntax. We're using it on the left side of an assignment statement, and that's taken to mean add this particular key value and this particular key and associate it with a value provided. And we need another school, so we'll use, what schools do we have? Let's use Indiana. The value will be Hoosiers. Just to make sure that it worked, let's print my dictionary. This syntax lets us add an element to the dictionary. What if we want to add an element that's already there? Let's say that we, for some reason, Xavier changed the name of their mascot. I'm not going to say anything about that. They changed it to the, I don't know, sword fighters. Those are kind of like musketeers. That will go in and locate the existing key value pair with the key Xavier and replace that value with sword fighters. Good deal. So we can add a key value pair, or we can update an existing value based on the key. It's a rudimentary database. How about iterating over the contents of the dictionary? Now, we've learned already that we can start a loop with the keyword for. And can we say key in my dictionary? And then print my dictionary, bracket, key, close bracket. Let's try that. How about that? And again, when I use that key as my variable name, that is completely arbitrary. It does describe what's going to be put in there because I know I'm getting the keys one at a time from the dictionary, but I could call that whatever I like. So that's not a reserved word of any kind. Okay, so we've seen several ways to manipulate dictionaries. Let's imagine some other things we might want to do. How about convert a dictionary to a list? Does that make any sense? We're just doing some thought experiments. A list is a set of individual values that are not necessarily related. They are all in the same container. It does not have the concept of a key value pair. So does it make sense to take a dictionary, which is sets of pairs, and convert that to a list? Well, it might make sense to maybe take out the keys or maybe take out the values and make those into a list. We just want a list of the keys. And if you look back at the previous slide, we can adapt the code that we already wrote to do that. Now let's make a list. We'll call this my keys, and the list will be empty, open bracket, open square bracket, close square bracket. So this is an empty list. We've established then that Python will know what to do with that data type. And then inside the loop, let's just append things to that. myKeys.append. I'm sorry. Yeah, that's right. And key. Finally, when we're done, let's print out my keys. And there's a very easy, quick little loop to extract all the keys from a dictionary into a list. But wait, there's more. There's probably other ways to do it, and there's probably ways to do it that require less code. Let's take a moment and do some research. And let's say Python dictionary keys to list. DuckDuckGo is way ahead of us. First hit says get dictionary keys as a list, and that's Geeks for Geeks. Second hit is pythonexamples.org, and this says convert Python dictionary keys to list. Both of those describe what we want to do. Third one is Stack Overflow, how to return dictionary keys as a list. Looks like there's lots of people that want to help us. Let's just take the first one. And they are showing multiple approaches. They are. The second approach, which they call the naive approach, is to do the exact same thing that we did. Well, pretty much. And they iterate over the keys collection in the dictionary, extracting the keys one at a time and appending them to a list. And that differs from our code in that we didn't specify dot keys, but our code worked just as well. If I add the dot keys to the iterator, let's see if it still works. Still works. All right, that's their naive approach. Fine, I agree with that. How about approach number 3? All we're doing is typecasting, or doing a dynamic type conversion of the keys collection into a list. One line of code. Don't need the for loop to iterate over anything. Just call the list function. Well, it's actually a list constructor for the list class, but we're not going there. And that converts it into a list. We should be able to do that pretty easily. Let's try that down here. And that's going to be my keys equal list paren my dictionary dot keys. Print it out. Bada boom, that works too. The point being there are different ways to do the same thing. I will be very specific if I care how you do it. In the context of an assignment, if I want you to use the list function, so to speak, the list constructor, I will ask you to do that. If I want you to use a for loop and iterate over the keys in the dictionary, I will tell you that. But if I just ask you to convert the dictionary keys to a list, then you can do it either way. And if I ask you to do that and you looked it up, and you got it to work in the context of the assignment, then you're successful. We can create an empty dictionary the way we created an empty list. I am back on slide 5. And we can do it two different ways. We can use the open and close curly braces. Or can we? Dun dun dun. And we can use the dictionary function, which is the constructor for the dictionary class. Again, two ways to do the same thing. There's a little caveat here on the slide. What is 0, comma in curly braces? So apparently, the author of the slides, which would be me, wants us to think about that little variation on our syntax. So let's do that. Let's go all the way back to Jupyter Lab again. In a brand new cell, my dictionary equals open curly brace, 0, comma, close curly brace, and we'll just add a comment to build suspense here. What is this? Apparently it's different from just including a 0 in the braces. And let's just print out the type of that. And we get a set. Okay. So if you don't if you add that comma, you get a set. Now stop and think about that. The reason that is a set, and let's contrast that with a dictionary let's just complete this thought here. We'll do the same thing without the comma. We'll say no, comma, this time. What is this? And that should be a dictionary, right? No, it's also a set. Can you make any sense out of that? Can you explain the difference between, and let's put the third one in there. Let's make it even more complete because we're getting down into the weeds and this is kind of fun. What is this? Here is an empty set of curly braces. Contrasting that with the other two examples in that cell. In the first example, inside the curly braces, we had a 0 and a comma. The second example, we have a 0. The third example, we have empty curly braces. And that gives us, finally, a dictionary. The difference is, I hope you've taken the time to stop and think about that a little bit, is that this is taken to be a value without an associated key. Therefore, it's a set. Because if you go back to slide 2 in the slideshow, a set is simply comma-separated values inside curly braces, differing only from a dictionary in that you're not providing something colon something key colon value separated by commas. And the only reason we're beating this horse to death is just to get you thinking about different data types and the nuances of writing your code. Also the nuances of reading your code and other people's code. All right, back to slide 5. We beat that one up. Let's move to slide 6. We've demonstrated this already. I showed you how to use the key lookup by the square bracket notation, the index notation, and the get function, one of which throws an error if the key isn't available and the other which does not. We saw that. We saw how to add a new item. Now this strategy for adding a new item is just a little bit different. In this case, we're creating a whole new dictionary and then calling the update function to put that dictionary into the existing dictionary. Let's take a shot at that. That's kind of interesting. Again, I will copy the code off of slide 7 and back to my Jupyter lab, a whole new cell, keeping in mind that I'm still working with this my dictionary variable, but I have a problem because in the previous cell I wiped it out. It's got nothing in it now. I'm going to go back and get this code way back at the top. The very first thing we did. Grab that line of code initializing this dictionary, which puts me in a known state. Now I'm 100% certain what's in that variable. I don't have to worry about what took place in other cells. I'm using the update function to add an entirely new dictionary to the my dictionary variable that I already have. I'm going to add Cincinnati State as the key, and then their team is called the Surge. I think they're green. Let's see what happens now. It simply added the key value pair to the dictionary. Not a problem. That worked well. What if there's two key value pairs in this dictionary that I'm passing in the update function? Let's add another key value pair. So let's add Ohio State as the key and Buckeyes as the value. This then is still a dictionary because it's inside those curly braces, but it has two entries and not just one. Let's try it and see what happens now. There it is. Okay. It added two entries to my dictionary. Everything went great, just like we'd expect. So we've seen two ways to add things to a dictionary. We've seen the indexing notation, and we've seen the call to the update function. I don't know which one is more efficient. If I had to bet, I would say that the first way that we discussed, which was way back up here, I think this way is more efficient because it doesn't have to create that intermediate dictionary and then merge it into the other guy. But I don't know for sure. I'd have to write some benchmark code and find out. Here's what I just showed you, calling update, where we're passing a multiple entry dictionary and it combines the two together. We've done that. We've already iterated. We've covered this. So we took our dictionary, we wrote a for loop, and we stepped through the individual elements. Notice in this case that I called my variable in the for loop team, which is a semantic representation of what's being stored in the key. And in the example in Jupyter Lab, I actually just called it key. Either way is fine. Remember, that name has no intrinsic meaning to Python. It's just a placeholder. So you can call it whatever you like. And I'm going to reverse that. Here's a little programming challenge for you. Take a moment, stop the tape, go get a cup of coffee, and open up a new cell in Jupyter Lab to cobble up this little program. I will write mine, and then I will be right back with you. Let's go look at my solution. I created a dictionary called data. and I decided it would be key value pairs consisting of a fruit and the price of that fruit. I just made up the prices. Then I dropped into an infinite loop. That loop will run forever because the condition will always be true. It will never become false. I printed a prompt. Enter a fruit and I will tell you the price is the prompt. I execute an input function call which stops the program, opens up a text box in the JupyterLab notebook and allows me to type until I press enter. And then I use that value typed in through the input function as a lookup into the dictionary. My test case was apple. It looked up the price of the apple and got $1.23, which is terrific. My second test case was one that's not in there, one that's going to fail. So there's no plum in the dictionary. And I get an error, key error plum. You'll get that a lot when you deal with dictionaries. Just be prepared to interpret that, and all it means is that you tried to look up something that's not there. Hopefully yours looks similar to this. You may have used different variable names, and that's fine. The next thing I want to do, according to the slide, is add error handling, because my program breaks very easily if the user enters something that's not in the dictionary. And I have forgotten, for the sake of argument, the syntax for error handling. So let's look it up. I'm using Google this time because I forgot to start DuckDuckGo, but I'll live with it. The first reference that comes up is python.org. That's the language reference, which is probably a little bit overbearing. There's probably a lot of things there that we'd have to fight through. The second one is Program IZ, which I've never heard of. The third one makes me happy, W3 Schools. That's the one I'll go to. Okay, it tells me I need a try block, an except block, and a finally block. I'm just going to skip down to the example because that's how I relate to code, is by example. Looks like I need try colon and except colon. So let's go to our code again. Let's put in a try. The try is going to contain all the lines of code that could fail. The only line of code that can fail, as far as I'm concerned, is that print statement because it contains the lookup. And that's what was giving us the key error. And then I need what? ERROR? No, I need except. EXCEPT. If I land in the except block, it's a pretty safe bet that the key lookup failed. I can print a message. Let's see, the thing is called fruit. Fruit plus is not on file. That's a nice message. And that's the end of my loop. I don't need a finally. I don't need to do something otherwise. All I need to do is attempt my print statement and then print something else if it fails. So let's try it now. Let's try apple. That still works, right? Good. Let's try plum. That should fail. There it is. It says plum is not on file. It loops back around again and it starts over. Very good. I do have a situation though because there's no way to get out of this program. I don't think Control-C works inside of a browser, does it? No. I cannot press Control-C. I can interrupt the kernel. Now that'll get me out, but that also, I think, clears all the environment, so I'd have to start everything from scratch again. But let's just do that anyway. And that causes an error. because it doesn't handle it very gracefully. It did get me out though. Okay. Let's add a little bit more logic to this. If you're following along with me, and I hope you are, I will ask you to, let's do something right here. Let's say, if the user entered quit, then break out of the loop now. Okay. 2 lines of code, or 1, depending on how you like to lay it out. Work on that for a moment. Pause the tape. Here's what I might do. If fruit equal quit colon break. Oops, sorry. That's how we get out of a loop. The break statement takes us out immediately without executing any more statements in the loop. And let's see if that works. Let's type in quit, enter, and we're out. We're back to the editor again. And I said you could do it in 1 line or 2. Sometimes, since we're used to doing it in an indented format, you might expect it to look like that, where the break is underneath the if. If there's only 1 line of code, I just put those 2 on the same line. I'm perfectly fine with that. I think it's convenient and easy to read. And that brings us to the end of our presentation. Thank you.